Hi, and welcome back. This video is going to go over the steps and the process here of solving a KSP, a solubility product equilibrium question. I chose an example again from your workbook. This is in question 19. I'm not sure what page it's on, but it is the last question in Unit 4, so you can have a look and find that example for yourself. And there are several examples in question 19 you can try. I should mention that. All right, so a KSP, what are we doing here in this problem? We are going to take an insoluble solid. We're going to take chromium 3 hydroxide, which doesn't typically dissolve in water. It's insoluble. We're going to put it in water, and it's going to dissolve a very, very tiny amount, right? A very small amount. These are sparingly soluble solids. When it does dissolve, it's going to reach a saturation point, a very low saturation point, and it'll create an equilibrium when it does that. And when it does, we are able to calculate what we call the molar solubility. How many moles of chromium 3 hydroxide could dissolve if I had a liter of water? So I'm looking for that saturation point. How many moles in 1 liter of solution? And it's going to be a pretty small amount because this is an insoluble solid. It doesn't want to dissolve in water. It's not something typical soluble like salt. So it's a little bit different. When you're given this question on your quiz and on your exam, you're going to most likely be given just the name of the insoluble solid and your KSP, and you're going to be asked to calculate its molar solubility. So just starting with the name, the first thing you have to do is write the chemical formula for chromium 3 hydroxide. Now that might be really easy for some of you, and for others, naming was last semester. Maybe we don't remember exactly how to write formulas and names of chemical compounds. So you might need to review that a little bit. We are going to do this one just based on its name. So chromium 3 hydroxide would be CrOH3. And like I said, that is a solid. That is an insoluble solid. I'm going to put it in water. It's going to dissolve a very, very tiny amount. It's going to create an equilibrium when it does that. And it's going to form 2 ions, right? It is ionic, so chromium 3 plus and hydroxide. And then, of course, it has to be balanced. I need a 3 in front of my OH because of the 3 from my chemical formula. So this is where the writing of names and formulas is going to be a little bit important. If you can't write a chemical formula from the name and then write a dissociation reaction from that, a balanced dissociation reaction from that, you're going to find this question to be a little bit difficult. So you may need to go back and kind of review how to do that before you attempt a question like this. All right, so when you get this part done, what's going to happen here is the chromium 3 hydroxide is going to start to dissolve, and it's going to start to separate into its ions, creates an equilibrium. At this point, you might want to set up what we call an ice table or a rice table, if you like. It's not necessary, but some people do find it a little bit easier just to sort of keep, kind of all your steps the same and keep them consistent. So a rice table, reaction, initial, change, and equilibrium. This is going to tell me my concentrations at particular points during my approach to equilibrium. So initially I have all reactant, I have no product, and that's the same for any reaction. So my initial for my chromium 3 and my hydroxide are 0, and that's always going to be 0 in this table when you do a question like this, because we're taking that chromium and dissolving it in water. Okay, so my product concentrations are always 0 to start. As we're approaching equilibrium, the chromium 3 hydroxide amount is getting smaller and smaller and smaller by some amount x. Right? We're not sure exactly what that is yet. And then at the same time, my product concentrations are getting bigger and bigger and bigger by some amount x. Again, we don't know exactly at this point what that is. But taking into account my mole ratio, my hydroxide, oh, I'm sorry, this should be a positive. This is plus x because it's getting bigger, sorry. That hydroxide should be a plus 3x because of the mole ratio. For every 1 chromium hydroxide, I'm going to get 3 hydroxide. So it's going to grow 3 times as fast. At equilibrium, I'm not overly concerned about what's here on my reactant side because they're not going to play a part in my KSP expression, but I do want to know what my product concentrations are. So 0 plus x will give me x. 0 plus 3x will give me 3x. Okay, just going to move my paper up a little bit here so we can see. Now, I know what my concentrations at equilibrium are. So right now, I'm going to write my KSP expression. KSP, just like KC, KP, KA, KW, products divided by reactants. In this case, my two products, Cr3 plus times hydroxide. That hydroxide is cubed, again, because of my mole ratio, because of my 3 here. This is my products. I would normally be dividing by reactants here, but my reactants are solids and liquids. Chromium 3 solid and, chromium 3 hydroxide solid and water. And we know that we don't include solids and liquids in K expressions. So my KSP is very simply the concentration of my two products, and that's it. Now at equilibrium, I know my values here for chromium 3 and for hydroxide, so I'm going to put them into my KSP expression. This would be x, hydroxide is 3x, and that is all cubed, so 3x all cubed. That's a very common mistake that people make in this question. Right now when they're going to do their calculation, they would say 3x cubed instead of cubing the 3 as well. So make sure not to do that. This would be now 27x cubed times x, so 27x to the 4. I know KSP because that was given way back in the top of my example here, 1.6 times 10 minus 30. Okay, so I can solve for x. X is going to equal the 4th root of KSP divided by 27. So get your calculator, make sure that you can do cube roots, 4th roots, and even 5th roots in your calculator. All right, so KSP divided by 27, and then we want to do the 4th root of this. So how do we do that? I got to think about it myself. How to do a 4th root. So I'm going to get 1.5, and thinking about how many sig figs I'm going to need here. Oh, I'm going to need 2. Scratch that. 1.6 times 10 minus 8, and this is of course moles per liter, but not really like a concentration. I think it's more like I can dissolve this many moles in 1 liter of water. So it's going to be a pretty small amount because chromium 3 hydroxide is an insoluble solid. And all of our KSP examples are going to be like this. They're going to be very tiny numbers for your molar solubility, which makes sense because this is a sparingly soluble solid. It doesn't want to dissolve in water. It's not like salt or sugar where you can dissolve a whole lot of it, in a liter of water. So for that particular question, I would really suggest trying some of the examples in question 19, and I think all of them, except for the very first one, are examples where you're going to have squares or cubes or 4th or maybe even 5th roots. So those would be great ones to try and practice because similar to your titration examples, you're probably not getting something that's like a 1-to-1 ratio. You're going to have 1-to-2, 1-to-3, 2-to-3. It's going to be something a little bit different for all of these, okay? So try through the examples in question 19. Use your solutions online if you need to. You can email and ask questions. You can ask in class, but definitely want to give some of these examples a try. And every single one, you can follow the same process and the same steps to answer this particular type question. All right, that's it for this video. I hope that was helpful. And of course, let me know if there's anything that doesn't make sense or you're not quite sure of one of the steps in the process. Good luck with example question 19, and keep studying, keep practicing. Thanks for watching. Have a great day.